All right, chapter 7.
Do you guys all take notes?
No.
All right, we're looking at quadratics here.
It's the graphs, ain't it?
Well, we'll look at the graphs too.
Okay.
Yeah.
This is the graphs.
I hate graphs.
It sucks.
I don't hate them. I just strongly dislike them.
Okay, so quadratic function. Is to the power of 2. Is to the highest power of 2. So when I mean to the power, I mean its degree, so x squared. Okay. So y equals x squared more. So when you're so when the largest exponent you see in the function or equation is 2, you're dealing with a quadratic. Always. Okay?
And the largest power or the largest number?
Power. The largest exponent, yeah. Okay? We write quadratics as in general form. It's a general or standard. I can't remember what they call this in here. Okay, in general form, you write them like this. Okay, A, B, and C are any number you want. The only stipulation is A cannot equal 0. Okay, any questions so far? B and C could be 0, negative, positive, doesn't matter. A can be positive or negative, it just can't be 0. Because if A is 0, then the x squared is gone and you don't have a quadratic. Get used to the letters. They're not going
Letters for a
anywhere.
long time.
They're not going anywhere. Okay? Now, a quadratic. Now, if you guys remember in grade 10, you did y equals mx plus b equations, right? And they were all linear, straight lines. Quadratics?
Is these the curved ones?
Yes.
The up or down.
All quadratics, when you graph them, make the same shape. They graph the same shape. Okay. And it's called a parabola. Two L's wrong. Parabola, parabola. Okay? Every time. And it just looks like a U.
Either just this way or this way.
It's either going to be up or down. Okay? When it's up like this, our graph is positive. And then when it's down like this, we say the graph's negative.
Even if that thing is on the positive side of the...
Oh yeah, like it can be up here and it's still down.
Okay.
Okay? We'll get into that stuff in a little while. All right, so what we say if the A value, so if A, remember up here, if A is positive, the graph opens up. All right. Think of it as positive, smiley face, right?
Negative is a frowny face.
Right.
Damn.
Yeah. Oh, it's not that. Down. Okay. Positive, negative. This is one of the key things, super simple, that we will be coming back to over and over and over again. Okay? Question, Brent?
So no matter what, say the parabola, whatever thing,
Parabola.
is placed further down on the graph, is it still positive?
Yes.
up?
If
Like-
it curves upward, it's always possible.
Like if it's like this, let's say, and I'm way down here like this, below the x-axis, still positive. These are just shifts in translations that we'll get into in a little bit, okay? They move the graph. That's what your B and C values do. They'll move everything this way or this way, okay? Any other questions so far? I don't really get into a whole lot of that today. Well, maybe we'll just stick to the textbook this year. I usually deviate and put stuff together. Let's talk more about the A value. Okay. So if A is greater than 1. Oh, it should be the absolute value. If A is greater than 1. Yeah, Nate.
There's nothing else.
Yeah, so just look it over, okay? Try following along with example 1 there, okay? So if A is greater than 1, we say the graph is narrow. It's going to be opening up skinnier, okay? So what I mean by that is, like let's say, this is my regular graph. Okay, so here my A value is positive 1. If I was to graph beside it, my A value is now 2. Graph of this. Does that make sense? Like I've kind of like just squeezed it together. That's called a squeeze or a stretch, sorry. And then if A is less than 1, so the absolute value. So if A is a fraction now, or a decimal, let's say I'm going to graph now. Well, I'll use this. Anyone want to take a guess at when it's a fraction, what's going to happen?
It's gonna be wider.
Right, it'll be wide. Wider. Okay. How you guys feeling so far? Fine? Okay.
Okay, harder.
This is 7.1. We got all the way to 7.8. And there's word problems.
No, it's
I don't know, it's 7.8.
you said there was no 6.
He
Okay.
did, and then he said 8.
Okay. This might be all I do with you guys today. Just give you some of the intro stuff to work on. Okay. You guys feel okay with the problem? It's a U. Up or down. Okay.
Big or small?
Wide or narrow. Okay. Positive, negative.
So Barney, you need to know your ups and downs.
Brennan, which way is that?
Did you say British?
There's
Oh.
Brennan.
I guess I should also tell you. Let's quickly just cover this.
Okay.
Well, 4. This guy here in standard form. We know what my A value. We know what the A value does, right? Positive, negative, narrow, wide, or normal. The C value is also another big one. It's the y-intercept of the graph. All right. So that's where it starts to move the graph around. So we need to cross the y-axis at a point.
Is B the x-intercept?
No, that would be too nice.
Okay.
Yeah, it's too easy.
That would just work.
Well, I just thought I should ask.
No. I'll get, what
I
is
don't need to know that yet.
B value? B value just shifts the graph. We don't get into really what the B value does here. Okay? We'll find other things though, like the x-intercepts. Believe it or not, like let's say there's my graph, right? There's 5. Something like that. This point here, where the graph comes down and then goes back up, change in direction, that's important. That's my vertex. Okay, and we'll get more into that later on.
The vertex of your curved line?
Yeah. Okay. Because what this is, see how my graph goes up or it heads down then back up? This is my lowest point on the graph. This is my minimum value. That vertex is the smallest value, which becomes important later on.
So that'll be the bottom.
Right. Or if my graph was to have done this, my vertex is my highest point, or my maximum value.
Right.
And my min-max, okay?
If it was y equals negative x squared, it should be the other way.
Right. Okay.
Top would be at 5. So.
Yeah, if there's a negative there, we would do that. Okay. So these min and max things, we'll do a bit of that here. You do a bit of it in grade pre-calc. You do a bit of it in grade 12. You do some of it in calculus. Okay. Because finding like the biggest amount that you can do something with, or the smallest amount that you can do something with, is kind of important. Okay. It makes things more efficient, or yeah, basically more efficient. Maximum profits, minimum loss, stuff like that. Minimum amount of materials needed to build something. Okay. So that's how this works. All right. So for you guys today to try. On page 360. One, 2, 5, and 6. Okay. You guys should get done early today.